good morning, or shall I say good afternoon, although it is late at night, just before midnight. So I hope I'm whispering now because everyone in my house is sleeping and you are sleeping. Although when you're watching this video, you should be all awake. So welcome to Practical Week in your IT class. So it's going to be, I don't know how it's going to work, how it's going to turn out, but we're going to try our best. So I'm actually very excited, and I think you are also excited to move away from the theory and to actually move over to some of the, to continue with our practical work. So today we're going to look at variables, different types of variables, different ways of which we name these variables. But we're going to start by defining what a variable actually is when it comes in terms of with regards to programming. So I'm going to bring up my screen. That's your textbook that we're going to work out of. So we are covering today, or the work that you're going to cover today is data types, unit 3.1, as well as variable and component names, unit 3.2. So we're going to skip through all of this. If you want to, you can read through this, but it's simply an introduction. But I will actually introduce it as we go along. So in this chapter, we will look at different data types and the naming convention that comes with this, variables, how we're going to declare them, assigning values to variables and converting them, and then understanding fixing basic programming errors. Not everything today, as I said, only the first two for today. So a variable is basically a container that can hold a specific value for a specific time while the program is running. It is actually space on the RAM that is kept for data to be stored in when needed. Why? Because when we do calculations, we need space where we can store answers or values in temporarily before we can use them again. Now, I don't want to confuse you too much, so we simply for now just call it a container, an invisible container that can hold data of a specific data type. So we have different data types, and we're going to look at, I think, 6 different ones for now. But a variable can only hold one value at a time. We can change that value so that throughout the duration of our program, that variable can actually change. And that's what variable actually means, a value that can change. On the opposite of a variable, we have a constant. A constant value is something that does not change. For now, we are only looking at variables, values that can change. So let's look at the different data types that we have. Okay, so we have string. So when we talk about in terms of programming, any type of text is called string. Strings are made of a sequence of numbers, letters, symbols, etc. Now, even a number 1, 2, 3 with apostrophes next to each other is actually string. It's text, although it's number, but the number is displayed or stored as text. For example, a cell phone number. It's a number, but we consider it text because we don't do any calculation with it. So a number only becomes a number once we are doing calculations with them. Anything else is text. And text in Delphi has single quotes at the beginning and at the end. So we have Stefan over here, password true as the word. The brown fox jumps over, so it can be sentences, can be words, it can be numbers. Okay, So a string must include it between single quotation marks, as shown above. A number within quotes refer to a string. This means that it cannot be used in numerical calculations. Okay, that's the first data type. The second one is char. That stands for a character. It's a single character. It cannot be 1, 2, or 3, or 4, or any two characters. It's either a special character or a number, but a single one. Okay, again, because it is text, it needs singular quotes. Then we have, now we're getting to our number data types. We have an integer. An integer is a whole number without any decimal points. It can be a positive number, but it can also be a negative number. And they now can be used for calculations. So now example that's given here, 100 minus 5, 12435. Also a number is one with a decimal number. So in Delphi we call them real numbers. So it's a variable with real data type. You can perform numerical calculations where the result will be a number with a decimal number. So 12.3. Even 1.0, although we know, or minus 1.0, although we know that is actually minus 1, which is an integer, but the decimal, even the 0, we have to declare that as a real variable because we are displaying a decimal. And then we have a Boolean. A Boolean is something that has two values. It's either true or it's false. So this is often used in programs where a specific task is only complete if a specific condition is met. For example, if the age is above 18, you may vote. So we ask a question and the answer is yes or no. True or false, it can also be 0 or minus 1, or there's another way, and I'm forgetting now. True, false, minus 1. Minus 1 is true, false is 0. And there's a third one. If I think of it, I will come back to that just now. So these are the most common data types: string, character, integer, real, Boolean. Another data type that we are going to look at this year still is that of T-date, which can store a date in them, but we are going to cover that a little bit later. Okay, now this is a guided activity, so in class I would have done that with you, so let's try this out. And I've actually tried something here to see if this can work. So Kagiso, I'm not sure how this is actually working. Nope, that's me. So we're definitely not wanting to go back there. Okay, I don't think my Zoom is on, so I can't really zoom in. So let's just talk through this manually. Okay, so Kagiso, we have a variable that must hold the name Kagiso. So that will be, and I'm pausing on purpose so that you can say it out loud. It's just you and the computer, so just say it. String. 17. An integer. A question mark. A character. 14.3. It's a real because it's got a decimal point. False. Boolean. Boolean. Numbers should be stored as integers. This is a sentence, so it is string. 005, it's a whole number, so it's integer. 18,142 point blah blah blah, it's a real because it has decimal places. True, Boolean. 12I34 is string because it has a character in the middle of the number. Right, I would like you to do activity 3.1, and yes, so 3.1.4 says list the variables you will need as well as their types. So over here, just as an example so that you can do this, name of school. Now maybe you must wait with this activity, do this activity once we're actually talking about the variable names. However, you can already say, for example, we need a variable for this school name. It's a string. The ID number is a string because we don't do any calculation with it. Age would be a number because we would calculate the average age, etc., etc. Male or female, gender, would be a character because it's either just M or F. But now let's look at how we are going to name our variables. There's a very specific, what we call naming convention when it comes to our variables. And it is very simple. So variables have a very descriptive name. So for example, school name. We literally write that. I'm going to add a sticky note, for example, here now for this one. Let's see if I can enter a sticky note. I cannot. There it is. No, that is not it. We're not editing the PDF. There we go. So I'm going to add now my note over here. So our variable name for name of school would be S for string. So our variable name always starts with the first letter of the data type of that specific variable. So in this case, S, and then there's no spaces, nothing else. So I would call it, I will take a capital letter, school name. So that would be my data type. And I'm just jumping a little bit ahead. If we declare it, we would now declare it with a colon, and we would say it's string. So if we would add another sticky note for the gender here, for example. So here I would say, because it's a character, I would say C, and then I would say gender. And you can see it's a small letter for the data type, and then I capitalize the first letter of the name. See, gender, and then colon, and then this is char for character. And then obviously I mustn't forget my semicolon for end of line. As an integer, I would have I, and then H. And the date of birth would be, for example, now, we could actually say here DOB, date of birth. It doesn't have a specific, because our data type is T date, and the T is actually reserved for other naming conventions, so we don't include that. So it's an exception. But for the rest, if it's string, it's S. If it's Boolean, it's B. If it's real, it's R. So yeah, so naming rules, names are variable and component names must be unique, so they can't be the same. Names must not contain spaces. So that's why we use capitalization to say school name. We can use an underscore, which separates words, I personally prefer the capitalization of names. Okay, so names may not start with number, but they may contain numbers. So you can say, you know, S and then something with a number, but it cannot start with a number. Okay, so some, yeah, they call it a camel case with a capitalization. So here we have the table, S for string, character, integer, real, boolean, and we would use that as the first letter, and then they use the camel case to capitalize the first letter of each new word. Naming convention for components. So should describe the task they will perform or the data they will hold. So we've done this already last term, where we are very descriptive in the names that we are giving. So some of the components: form, FRM, button, BTN, LBL, image, and so on. Very, very important is Annexure C. So you can go to Annexure C at the end of this textbook and actually look at a detailed list of all the components and their prefixes. Very helpful for the first time in the 10 years that I'm teaching IT, is the textbook actually containing those prefixes. So please go and have a look at that. And then today you will just finish. I'm asking also you to finish activity 3.2, and this is where we're ending for today. So tomorrow we'll continue with declaring variables and components, but for today you will complete activity 3.1 and 3.2. Thank you guys, you are awesome.